In this video, we're going to make a connection between multiplicity and zeros and the shape of a graph of a polynomial. Multiplicity is a new word that we've heard before, but essentially for today, multiplicity is going to talk about these three shapes across a wiggle or a bounce. And what we're specifically looking at is the x-axis. So there's the connection to zeros, is x-axis is where we see the x-intercepts, and x-intercepts has several different names: zeros, solutions, roots. So we're going to call them zeros today. And what that zero looks like is what we're going to call multiplicity. So we're going to look at some familiar things: degree, leading coefficient, and then we're also going to learn this new shape of the graph, multiplicity. So to talk about the familiar degree is something that we've talked about before. That is the highest exponent, but we need to be a little bit more specific. It's when x's add or subtract. So the degree is the highest exponent when the x's add and subtract. We're also going to give it another way of finding the degree. It still has to do with exponents. It's the sum of the exponents when x's multiply. So if you take a look at the polynomials we have in our equations over here, we have 2x to the fourth and x minus 1. The one below that is negative 6x times x plus 1 to the fifth, and then on the bottom we have 3x times x minus 1 to the third, x plus 1 squared. You can see on all of those that the x's are not adding together. They do have some addition in there, but there's parentheses around them, or they're on the outside of the parentheses, which means they are multiplying. So our degree in this case is we're going to add all the exponents we see. So to get into the actual work, let's go ahead and start with the familiar. We're going to start with the degree. So for number one, the degree of our polynomial comes from adding all the exponents on x. It's either going to be right after the x or at the end of the parentheses that the x is inside. So for number one, we have a 4, but then at the end of this parentheses, there's no exponent. But when there's no exponent, it's not a 0, it's a 1. So 4 and 1 add together to make 5. Our degree is 5 for that first example. Our leading coefficient, that's still in the front. There's not necessarily standard form when it's multiplying, so this is called factored form. And when it's in factored form, your polynomial, the leading coefficient is always at the front. It doesn't matter the order. So the sign of our leading coefficient is positive, so I'll just put a plus for positive. And therefore, we can determine that this is an odd positive polynomial. So the right side's going to go up and the left side is going to go down. Our left end behavior is down, right end behavior is up. That's just the shorthand we are going to use. So for the first couple ones, you can pause the video here and graph these on Desmos if you'd like. I'm going to go ahead and graph them based off of what I know, but use Desmos for 1, 2, and 3. And then on the next page, we aren't going to use Desmos to look at them. So a solution, a 0, you can see in these equations here because they are in factored form. So factors relate to solutions. So for instance, this x produces a solution of x equals 0, which you can see is right there in that middle column. X minus 1, that factor, produces a solution of x equals 1. So the solutions, you can see, are going to show up on our graph. We are going to have an x-intercept at 0 and 1, so I'm going to put a dot there. And then I know that on the right side of my graph, I need to go up, and on the left side of my graph, I need to go down. Now the question is, how do I get between those points? This will actually look like that right there. Our graph will just touch the x-axis at 0, turn around, and then go straight through at 1. Desmos can confirm that for you. If you now look at our pictures up top, we can answer the question. Do we have a cross? Do we have a wiggle? or do we have a bounce? And we're looking at each individual solution. So let's start with 0. 0, we have a bounce. It touches the x-axis and turns around. It looks like this picture on the right side. At 1, we're going straight through. I know my pen looks a little wiggly there, kind of like a wiggle, but it does in fact go straight through. So this is a cross. The last thing that we are going to connect is the exponent. That has something to do with our multiplicity. So the exponent on each factor is what we're going to fill down here. So not the overall degree, but each individual exponent. So that factor with the parentheses, the x minus 1, that, as we said, had an exponent of 1. And then the 2x to the 4th has an exponent of 4. We are going to see some patterns emerge from this. So you might not have all of the patterns so far, but let's continue on with number 2. So number 2, going back to the familiar, let's start with degree and leading coefficient. So my degree is 1 from that x outside the parentheses on the negative 6x, and 5 from the x plus 1 to the 5th. That 1 and 5 will add together to make a degree of 6. Our leading coefficient is negative, so if we look, we have an even degree and a negative leading coefficient, so our end behavior is going to go down on the left and down on the right. That's always the case for a polynomial with even negative leading coefficient and degree. So now let's look at our solutions, our roots, or our zeros, whatever you want to actually call them. Once again, we have an x. That's going to make a solution of x equals 0. But this time we have a solution of x plus 1. That will make a solution of negative 1. So you can see we've x'd out the box for x equals 1 this time. You can graph this on Desmos. I'm going to graph it by hand. It will, in fact, look like down, just like that graph right there, or something similar. So we can fill out our exponents like we did at the end last time on number 1. Our negative 6x only has an exponent of 1, so our x equals 0 is going to have an exponent of 1. And then our exponent for x plus 1 to the 5th, well, that's just the to the 5th, the 5 part. But now let's actually figure out our bounce, wiggle, or cross. So we need to look at the pictures up at the top of our paper. We see at negative 1, it goes through the x-axis, but it doesn't go straight through, it wiggles through. So this, in fact, is a wiggle for x equals negative 1. Then, looking back at 0, that does go straight through, so that is, in fact, a cross. So we're starting to see some patterns here. You might notice that from number 1, we crossed and we had an exponent of 1. And then on number 2, when we crossed, we also had an exponent of 1. That connection right there is a pretty significant connection. Let's see what happens for bounces and wiggles. Let's see if we can figure it out on number 3 here. So for number 3, we have y equals 3x times x minus 1 to the 3rd times x plus 1 squared. Starting with our degree, we're going to add up our exponents. We have a 2, we have a 3, and then on the first x, we also have a 1. So our degree is once again 6. And our leading coefficient this time is positive, so we have plus and 6. So our end behavior is even and positive, so both sides go up. We have solutions of x equals 0, x equals 1, and x equals negative 1. So we have 3 different x-intercepts that we're going to put on this graph, so just go ahead and put a dot at negative 1, 0, and 1. And then we can also fill out our exponents, just looking at the factors here. The exponent on our factor of x plus 1 is a 2, so that exponent will be 2 for x equals negative 1. The exponent on x equals 0, the factor from x equals 0 is 3x, is just a 1. So in the middle, x equals 0, we have a 1 as our exponent. And then on our factor x minus 1 that produces the solution x equals 1, we have an exponent of 3. So there's all of our exponents broken down. You can graph this on Desmos. I'm going to go ahead and look at it and graph it. So my graph matches, the end behavior is pointing up, Now we just need to figure out, do we have cross, wiggle, bounce at each of our solutions? So starting with -1, that's definitely a bounce. It does not go through the x-axis. So our -1, 0 has a bounce at it. And then our 0 goes straight through the x-axis. It doesn't do anything funky there. So that is in fact a cross. And then our solution of x equals 1, that goes through the x-axis, but it flattens out along the x-axis. So that is in fact a wiggle. So some of the connections that you should have noticed is definitely the 1. Whenever you have a solution with an exponent of 1, it's going to cross the x-axis straight through. There's no wiggles, there's no turning around, it just goes straight through the x-axis. We're going to call that a cross. If you have an exponent that is even, look at number 1 and number 3, we have even exponents on the x equals 0 factor or solution for number 1, and then for the x equals -1 for number 3, we have an even exponent. Those both bounced. So even exponents are going to bounce. That means that any odd exponent other than 1 is going to be our wiggle. So we can write that up at the top. An exponent that is 1 is a cross. An exponent that's even is going to be, oh, I wrote that in the wrong spot. An exponent that's even will be a bounce. And then an exponent that is odd, and you can put in parentheses, not 1, is going to wiggle. So now we don't even need Desmos to actually graph these graphs. So if you go to the next page, we're going to do some more of these, and these are going to show us the exact same pattern. It will be consistent to what we just discovered on the front, and then we'll fill in our boxes at the bottom to actually have that rule written out. So starting again with the familiar, let's get our degree down. The degree for number 4, well, we have -5x, that's a 1, x minus 1 to the 6th, that's a 6, and then x plus 1 to the 7th, that's a 7. So 1 plus 6 plus 7 is a degree of 14. So we have an even degree. And our leading coefficient is negative, so our end behavior should go down and down. We have all 3 solutions. Let's put our exponents for those 3 solutions. So for x equals 0, the first one, we have an exponent of 1. For x equals 1, be careful, factors and solutions are opposite. We have an exponent of 6, so that's an even exponent. And then for x plus 1, the solution is x equals -1, we have an exponent of 7. So let's make a prediction as to what these 3 solutions will look like. Well, cross is, in my opinion, the easiest one. An exponent of 1 is a cross. Even exponents are going to bounce, and then odd exponents other than 1 are going to wiggle. So let's sketch our graph now. Put your x-intercepts at -1, 0, and 1. We have end behavior that's going down. On the left x-intercept, we need to wiggle. In the middle, we should cross. And then at 1, we should bounce. So, coming up, flatten out, cross through, and bounce off of 1. That is how that graph should look. It's just a sketch. It doesn't need to be perfect. As long as you have a wiggle, a cross, and a bounce in that order, moving across, you are good to go on number 4. Looking now at number 5, we have y equals -5x squared times x plus 1 to the 3rd times x minus 1 to the 4th. So all those exponents added up are going to give us a degree of 9. Our leading coefficient is negative, so we have an odd degree with a negative leading coefficient. That's going to be up on the left, down on the right. And then our solutions, or zeros, are going to give us our exponents here. So I'll start with x equals 0 with that -5x squared. The exponent there is 2. Let's just go ahead and circle what that does. An even exponent will bounce. X plus 1 to the 3rd, that's a 3 for x equals -1 as our 0. And that is an odd exponent, but it's bigger than 1, so that's going to be a wiggle. And then the last 0, x minus 1, will make x equals 1. That has an exponent of 4. That's an even number as well, so that's going to be a bounce. So this graph has all three x-intercepts, -1, 0, and 1. And we need to go up on the left, down on the far right, with a wiggle, and then 2 bounces. So I'm going to start up, flatten out, bounce, bounce, and go down. Once again, these are sketches, so my graph is not beautiful. If you type this equation into Desmos for number 5, it'll make you a pretty graph that looks really good. It should look something like my graph in terms of general shape, but we have now been able to sketch it just from looking at the equation. Number 6, let's go ahead and start with the degree again. We have 4x squared, x minus 1 to the 5th, and x plus 1. So we have a 2, a 5, and then that hidden 1 makes 8. So our degree is 8. And our leading coefficient is positive. So our end behavior for an even positive polynomial is up on both sides. And then my solutions, we'll start with 4x squared. So x equals 0 has an exponent of 2. That's an even number. Even numbers will bounce. My x minus 1 has an exponent of 5. That's the solution x equals 1. That's going to be an odd number bigger than 1, so that's a wiggle. And then x plus 1 will be x equals -1, apologies. And that is an exponent of 1, and that's going to be a straight through cross. So put your solutions, your zeros, on the actual graph axis, and then let's sketch it. We need to end up on both sides with a cross, then a bounce, then a wiggle. So I'm coming from above, straight through, bounce off 0, and then flatten out and wiggle through at +1. So we've now seen that graph. It kind of looks like a wonky W on the right side. It's flattening out a little bit, but we have a little bit of a W there. Last one, number 7, we have y equals 200x squared times x minus 1 to the 5th times x plus 1 to the 6th. So 2, 5, and 6 are going to determine our degree. We have a 2, a 5, and a 6 added together to make 13. That's an odd number. And our leading coefficient's a big number, 200, but that doesn't matter. All we care about is the fact that it's positive. So odd positive is down on the left, up on the right. Now looking at our solutions, 200x squared is an exponent on that x of 2. So x equals 0 has an exponent of 2. That's an even number. Even numbers bounce, you know it by now. X minus 1 makes the solution x equals 1, and there's an exponent of 5. That's an odd number bigger than 1, so that'll be a wiggle. And then x plus 1 to the 6th has an exponent of 6, and that's an even number, so it's going to be a bounce as well. So we need to put our solutions on the graph, -1, 0, and 1. And when we go through, we need to go down on the far left and up on the far right with a bounce, and a wiggle at each of our solutions. So starting going up, bounce off of -1, bounce off of 0, and then flatten out at 1, and then go all the way through. There is your graph for number 7. If you put this into Desmos, it probably looks a lot thinner or looks a lot longer in certain areas, but the general shape of this graph is what we just drew right there. So to finish this out, let's condense what we've been talking about into these note boxes at the bottom. So for number 8, it says, what do you notice about the exponent on the factor in each equation when the graph crosses through a 0? We've talked about it. A cross is an exponent of 1. Awesome. Number 9 asks the next question. What do you notice about the exponent on the factor in each equation when the graph bounces off of a 0? So for bouncing, the exponent is always even. And the last box brings it home. It says, what do you notice about the exponent on the factor in each equation when the graph wiggles through a 0? So this one was the toughest. It's an odd that's bigger than 1. So the exponent is bigger than 1 and odd. So now we can graph polynomials in factored form just from finding the degree, the leading coefficient, the x-intercepts or the zeros, and then the multiplicity tells us, does it cross, does it bounce, or does it wiggle? So multiplicity, we're basically just looking at exponents to determine that. Is it 1, is it even, or is it an odd number bigger than 1? That's what we just did on these notes. Now you can graph polynomials that have been in factored form.